we are discussing about one of the important topic from the organic chemistry, heterocyclic compounds. लास्ट लेक्चर मध्ये आपण या टॉपिकची सुरुवात केलेली होती. यामध्ये इंट्रोडक्शन मध्ये आपण काय स्टडी केलेलं होतं? व्हॉट इज मीन बाय हेटेरोसायक्लिक कंपाउंड? Actually, these are cyclic compound which having at least one hetero atom, means oxygen, nitrogen or sulfur in its structure, and that compounds are called heterocyclic compound. Then we also studied importance of heterocyclic chemistry, then classification of heterocyclic compound based on two different modes, and we have started first very important heterocyclic compound, Pyrrole. Pyrroleचं डिस्कशन आपण लास्ट लेक्चर मध्ये सुरुवात केलं होतं. व्हॉट इज मीन बाय Pyrrole? Actually, this is 5-membered nitrogen containing heterocycle, and we have studied some synthetic methods, some synthetic preparation methods by the Pyrrole, how that compound is prepared in laboratory. Now let us see electrophilic substitution. Okay, this is Pyrrole compound. We know that Pyrrole is a aromatic compound. It having 6 pi electron. It shows general electrophilic substitution. Now, why the Pyrrole shows electrophilic substitution? Because in Pyrrole there are 6 pi electron. Means there is electron cloud over and below the plane of ring. Hence, electrophile. Suppose this is the electrophile. It can be easily attacked on the Pyrrole because there is electron cloud over and below the plane of ring. Hence, electrophiles can be easily attacked and it undergoes electrophilic substitution reaction. Now question arises, at what position electrophile attack on the Pyrrole? After electrophilic substitution, what should be the product? Is it 2 substituted or 3 substituted? This is the question. Okay, now electrophile attack on the Pyrrole and it gives intermediate which is resonance stabilized. Suppose this is our Pyrrole. In first step, suppose attack of electrophile takes place at position 2. The bond between 2 carbon atom is undergo breaking and new bond between that position 2 and electrophile takes place. या दोन्हीच्या मध्ये नवीन बॉन्ड तयार होतो. Means that pi bond undergo breaking and new bond between that position 2 and electrophile is formed and we get the intermediate. This is intermediate. Now what should be the charge on position 3? This should be acquire positive charge. Now let us see how that intermediate shows resonance effect. Here this pi bond shifted towards electron deficient carbon. हा pi bond इथं शिफ्ट होतो दोन्हीच्या मध्ये. Therefore now this carbon acquire positive charge and we get the new intermediate. Okay, this is the new canonical structure. Here pi bond and there is a positive charge on this carbon. इथं positive charge असेल. Now again it undergo delocalization. How the delocalization occurs? We know that this nitrogen having electron pair. Now this electron pair goes towards electron deficient carbon. Electron pair इथं pi bond तयार करते and there is a formation of new intermediate. Here pi bond, इथं pi bond असेल and therefore nitrogen acquires now positive charge. यावरती positive charge येतो and thus when electrophile attacks on the Pyrrole at position 2, then we get intermediate and which is resonance stabilizer. It shows resonance effect. Now let us see similarly what happens when electrophile attack on the position 3. Here also that pi bond undergo breaking and new bond between position 3 and electrophile is formed. त्यामध्ये नवीन बॉन्डचं फॉर्मेशन होतं while this carbon acquire positive charge. Okay, now this intermediate also undergo resonance. There is also delocalization. Now how it shows the resonance effect? There is lone pair of electron on the nitrogen. This electron pair form a pi bond between these two atoms. Okay, there is a formation of pi bond between these two atoms while that nitrogen acquires positive charge. This is the resonating structure for the that intermediate. Okay, and thus when electrophile attacks on the Pyrrole at position 2 as well as position 3, we get the intermediates and that both the intermediates undergo resonance effect. Both are resonance stabilized. We know that if any species shows the resonance effect, then that species becomes stable. We know that more is the number of canonical structure, more is the stability. Now, which intermediate is more stable among that two when attack takes place at position 2? Because this intermediate having 3 canonical structure and therefore this intermediate is more stable than second. When electrophile attacks at position 2, we get the intermediate which is more resonance stabilized than the intermediate when the electrophile attack at position 3, because it is less resonance stabilized, and therefore Pyrrole undergoes electrophilic substitution more easily at position 2 than position 3. This is the reason why Pyrrole undergoes electrophilic substitution at position 2 than the position 3. Let us say general mechanism. Electrophile attacks on the Pyrrole at position 2 to form intermediate which is resonance stabilized. When electrophile attack at position 2, what happens? Pi bond undergo breaking. There is formation of new bond between position 2 and electrophile. Position 3 acquires positive charge. We get the intermediate. This intermediate is resonance stabilized. आत्ताच आपण बघितलं how it shows resonance effect. इथला pi bond break होतो. There is formation of new pi bond between these two atoms. This carbon acquire positive charge. We get the next canonical structure. Again there is a delocalization of electron. This lone pair of electron form a pi bond here. इथं pi bond तयार करते and we get the another resonating structure. Then this intermediate, हा intermediate पुन्हा काय होतो? This intermediate loses proton. This is the intermediate which loses proton. म्हणजे काय? The bond between carbon and hydrogen undergo breaking. And this electron pair now form a pi bond between these two atoms. यामधले इलेक्ट्रॉन पेयर या दोन्हीच्या मध्ये pi bond formation करतं. Here there is a formation of new pi bond and therefore there is a loss of H plus ion. Pyrrole undergoes electrophilic substitution at position 2 and we get the desired product, we get the expected product, and this is the general mechanism for any electrophilic substitution. मग ते nitration असेल, it may be sulfonation, it may be Friedel-Crafts reaction, halogenation reaction, etc. This is the general mechanism for electrophilic substitution. We also studied how the Pyrrole undergoes electrophilic, why at position 2. Actually, we are discussing about one of the important topics from the organic chemistry, heterocyclic compounds. We have studied first heterocyclic compound in detail, Pyrrole. Pyrrole is actually 5-membered nitrogen-containing heterocycle. It having one nitrogen atom, and actually it is 5-membered aromatic heterocyclic compound. We have studied synthesis of Pyrrole. That means how this compound is synthesized in laboratory. Then second is the physical properties of Pyrrole. Then basic character of Pyrrole means how the Pyrrole is weak base, how it shows its a basic nature. Then also about the acidic nature of Pyrrole, and then aromaticity and resonance means how the Pyrrole shows resonance effect, how the delocalization of lone pair of electron is involved or delocalization occurs in the Pyrrole, how it shows the resonance effect, and why it is aromatic in nature, how it shows aromatic character. Actually, it is planar cyclic compound and also having 4n plus 2 pi electron, means 4 electrons of 2 pi bond and 2 electrons from the lone pair of electron. This total 6 pi electron means there is a 4n plus 2 pi electron, hence it is aromatic in nature. We also studied about how the Pyrrole undergoes electrophilic substitution reaction at position 2 with the help of its resonating structures, and then also about the general mechanism for the electrophilic substitution reaction shown by the Pyrrole. How the electrophilic substitution occurs, we have studied general mechanism. Now let us see some chemical reactions shown by Pyrrole. Let us see first one is Pyrrole is example of aromatic compound. Okay, it is heterocyclic but aromatic in nature, and therefore similar to other aromatic compound, it undergoes electrophilic substitution reaction. We have studied how it undergoes electrophilic substitution reaction at position 2. Then let us see some electrophilic substitution reaction. First one is the nitration. Okay, generally all the aromatic compound undergoes nitration reaction. Consider our example Pyrrole. Yes, this is the Pyrrole compound. Then it is treated with the concentrated HNO3, and that reaction is carried out in presence of acetic anhydride. This reaction is carried out in presence of acetic anhydride. Now what happens here? That concentrated HNO3 produces NO2 plus ion, means there is electrophile, and that electrophile attacks on the pyrrole at position 2 and it undergoes electrophilic substitution. Here hydrogen atom from the position 2, there is one hydrogen atom at position 2 and that hydrogen atom is replaced by electrophile. It is replaced by electrophile and then it undergoes nitration reaction and there is a formation of such compound. Just replacement of hydrogen atom takes place by NO2. Now what should be the name of compound? Yes, final product is the 2-nitropyrrole. We know that electrophilic substitution occurs at position 2. It occurs at position 2 and we get the 2-nitropyrrole. Okay, this is the simple but very important reaction shown by the pyrrole. Now let us see, next one is the sulfonation. Again, a very common example of electrophilic substitution, sulfonation. This is our compound pyrrole when it is created with the mixture of SO3, sulfur trioxide, and pyridine. Here, pyridine is basic in nature. Actually, it acts as a catalyst. That reaction is also example of electrophilic substitution. And here, hydrogen atom from the position 2, that hydrogen is replaced by sulfonic group, SO3H group, and we get the corresponding pyrrole to sulfonic acid. When pyrrole is treated with the SO3 in presence of pyridine, here it undergoes substitution reaction. Hydrogen atom from the position 2 is replaced by sulfonic group, SO3H group, and we get the pyrrole to sulfonic acid. And next example is the Friedel-Crafts reaction. Okay, this Friedel-Crafts reaction is also very common reaction shown by aromatic compound. And there are two types of the Friedel-Crafts reaction. One alkylation and second one is the acylation reaction. There may be alkylation or acylation reaction. Consider example, yes, same compound pyrrole when treated with the acetic anhydride CS3CO, so O again CO CS3. This is acetic anhydride. Always that reaction is carried out in presence of Lewis acid catalyst. We can use ZnCl2, FeCl3, SnCl4, etc. SnCl4 is example of Lewis acid catalyst. Lewis acid means compound which having tendency to accept electron pair. And this is example of Lewis acid and it acts as a catalyst for the same reaction. That reaction is carried out at high temperature near about 474 degree Kelvin. Okay, now what happens here? Here also same type of reaction occurs. Hydrogen atom, here that position 2 having one hydrogen atom, that hydrogen atom is replaced by COCH3 group. Suppose that hydrogen is replaced by COCH3 group and we get the corresponding two substituted product. This is COCH3 actually. Now what is the remaining compound? CH3, CO, that oxygen, and this hydrogen atom, it forms CH3COOH, means acetic acid is the byproduct. Okay, now what is the name of this compound? Yes, there is acetyl group at position 2. Therefore, the name of compound is a 2-acetyl pyrrole. This is example of Friedel-Crafts alkylation and it is electrophilic substitution reaction. Now let us see next one, halogenation. Halogenation means replacement of hydrogen atom from the aromatic compound by halogen. Okay, it may be chlorine, bromine, or iodine. Let us say example. Suppose that pyrrole is created with the bromine in ethanol. When it is created with the bromine in ethanol, actually in this reaction, all the 4 hydrogen atoms of pyrrole, they are replaced by bromine and we get the tetrabromopyrrole. When pyrrole is created with the bromine in presence of ethanol, all the 4 hydrogen atoms, here each carbon having one hydrogen atom, and that hydrogen atoms are replaced by 4 bromine atoms, and we get the tetrabromopyrrole. The name of compound is a 2,3,4,5 tetrabromopyrrole. Let us see one more example. Suppose that pyrrole is created with the iodine in presence of potassium iodide, Ki. So what happens here? Here also same type of reaction occurs. Here also same type of reaction occurs. Means all the 4 hydrogen atoms, they are replaced by iodine and we get the tetraiodopyrrole. This is 2,3,4,5 tetraiodopyrrole. Okay, and in this way, when pyrrole is created with the halogen, undergo halogenation. Suppose there is a bromine, we get tetrabromopyrrole. It is bromination.
Suppose we are using iodine and potassium iodide, then it is iodination. We get tetrahydropyrrole. Okay, this is example of again electrophilic substitution reaction. Let us see one more example regarding the electrophilic substitution. Again, pyrrole, when treated with the benzyl disonium chloride, that reaction is carried out in presence of H plus ion, means in presence of acid, and at temperature 0 to 5 degrees Celsius, means at very low temperature. Now what happens in this reaction? Here also hydrogen atom from the position 2. इथं असणारा जो hydrogen atom आहे, that hydrogen is replaced by this whole group. Actually, it is replaced by this whole group. Now that hydrogen and chlorine form HCl, and directly there is bond between nitrogen and that pyrrole carbon of pyrrole, and thus we get the corresponding product. And this is nothing but the example of azo dye. When pyrrole is created with the benzene disonium chloride, it undergo coupling. This is also example of electrophilic substitution, and that reaction is characteristic reaction shown by all aromatic compounds. And thus this is just about the electrophilic substitution reaction. Next reaction, oxidation. How the pyrrole undergo oxidation. Generally, what is meant by oxidation? Yes, we can simply say that if there is addition of oxygen, or if there is a removal of hydrogen, then that reactions are called oxidation. Now let's see how the pyrrole undergo oxidation reaction. Okay, now when it is treated with the chromic acid in presence of sulfuric acid, that chromic acid is a strong oxidizing agent. What happens? 3 nascent oxygen atoms participate in the reaction. Okay, now here that hydrogen atom, this hydrogen atom is replaced by oxygen. Similarly, that second hydrogen is replaced by another oxygen. Now that 2 hydrogen atom and third oxygen atom, it form H2O. This is H2O byproduct. Now that 2 hydrogen, this hydrogen atom and this hydrogen atom, they are replaced by, both are replaced by just oxygen atom. हे दोन्ही ही hydrogen atom जे आहेत, they are replaced by oxygen, and we get this compound. Replacement of hydrogen by oxygen means there is a removal of hydrogen, there is addition of oxygen, hence it is example of oxidation. Okay, and thus this is the amide, cyclic amide of the malic acid, therefore called malic amide actually. Okay, this is example of oxidation reaction. Let us see how the pyrrole undergo reduction. Now actually, how will you define reduction? Yes, simply we can say that if there is addition of hydrogen, exactly vice versa of the oxidation. Okay, what is the reduction? Addition of hydrogen or removal of oxygen. Pyrrole, when treated with the zinc metal in acetic acid. Now, actually, how the reaction occurs? Here, addition of 2 hydrogen atom takes place. 2 hydrogen adds to pyrrole, to the carbon atom number 2 and 5, and thus this is called dihydropyrrole. Addition of hydrogen occurs, hence it is example of reduction. Now this dihydropyrrole further on reaction with red phosphorus in HI, it is created with the red phosphorus in HI. Further it undergo reduction, and in this step again 2 hydrogen atoms adds to this C double bond C, means 1 hydrogen adds to this carbon, another hydrogen adds to this carbon, and we get the tetrahydropyrrole. Okay, actually in first step 2 hydrogen adds, we get dihydropyrrole. In second step again 2 hydrogen adds to this carbon, therefore we get the tetrahydropyrrole, and this is example of reduction reaction. Let us see another reaction of the same type. Yes, pyrrole, when treated with the hydrogen gas in presence of nickel catalyst, that reaction is carried out at temperature 473 degree Kelvin. This is called hydrogenation. In presence of nickel catalyst, that pyrrole undergo hydrogenation, and here totally 4 hydrogen atom, means 2 H2 molecule participate in the reaction. Addition of 4 hydrogen takes place to the 4 carbon atom, and we get fully saturated compound. And this is nothing but the again tetrahydropyrrole, and this is just example of reduction. By using different reagent, we have studied how the pyrrole undergo reduction. If we are using zinc and acetic acid, first we get dihydropyrrole, which on further reduction with red phosphorus, we get tetrahydropyrrole. And if we are using hydrogen gas and nickel catalyst, directly pyrrole is converted into tetrahydropyrrole. Okay, this is just reduction. Okay, we have studied three reactions regarding the pyrrole. First, electrophilic substitution reaction. Second, oxidation reaction. And third one is the reduction reaction. Okay, this is just about the very simple example of heterocyclic compound. Very simple, but very important heterocyclic compound, pyrrole. Okay, it is an example of 5-membered aromatic heterocycle.